Hello everyone, welcome to Civil Engineering and Stuff. And in today's video, we are going to discuss an interesting topic called floating car method. So in floating car method, this method is used to conduct speed and delay study. This method is used to conduct speed and delay study. So by this method, we want to find out the journey speed and the running speed, the time loss in between the study section, and the probable cause for this delay is find out using floating car method, and after that, the average journey time is assessed. All right. So in this method, what happens is that a test stretch is adopted. A road section that is under the purview of the study is selected, and a test vehicle, which is car in this case, has a name here, floating car. So the test vehicle, which is the car in this case, this car moves under the prevailing traffic condition. Now this test vehicle have four observers sitting inside it, right? We have observer number one, we have observer number two, observer number three, and observer number four. Apart from the driver, we have the four observers sitting inside the car. Now, as the test vehicle, as the test vehicle is moving in the prevailing road condition, each observer has certain specific role. So let us discuss what the role of each observer is. So the observer number one is equipped with two stopwatches. Observer number one has two stopwatches. Stopwatch one, that is one of the stopwatch. It is used to record the time of arrival at various checkpoints. It is used to record time of arrival at various checkpoints. So in between the study section, few checkpoints are decided. In between the study section, few checkpoints are decided, and the time required right from the start to reach the respective checkpoints are recorded by observer number one through the stopwatch. Then the second stopwatch is used to record the individual delay. Duration. So as the test vehicle is moving in the prevailing traffic condition on the study stretch, so of course it may face certain delay. It may be due to any reason. So the observer number one records how much time loss has been taken because of those individual delays. So that is the role of observer number one. Then we have observer number two. We have the observer number two, whose function is to record the cause of delay. Now observe as the time loss or the delay is happening, the observer number two records the probable cause of the delay. It may be because of the huge number of vehicles on the road. It may be because of the merging traffic condition because of which the congestion or delay takes place, right? So whatever be the cause of the delay, that is recorded by observer number two. Then we have observer number three with us. Observer number three, and observer number three records two things. The first thing that observer number three records is number of vehicles. It records the number of vehicles overtaken by the test vehicle. And it also records the number of vehicles overtaking number of vehicles overtaking the test vehicle. Number of vehicles overtaking the test vehicle. This means that as we have discussed that the test vehicle will be moving in the prevailing road condition. So during the prevailing road condition, the test vehicle will overtake certain vehicles to reach to the various checkpoints as well as the destination. So how many vehicles have been overtaken by the test vehicle? That is recorded by observer number 3, as well as during the movement, of course, certain vehicles will overtake the test vehicle and move ahead. So how many vehicles have overtaken the test vehicle is also recorded by the observer number 3. So this means that observer number 3 records the number of vehicles overtaken by the test vehicle and the number of vehicles overtaking the test vehicle. Alright, so these two are recorded by observer number 3. Then we have our observer number 4, and observer number 4 records the number of vehicles. It records the number of vehicles that are traveling in opposite direction of the test vehicle. Traveling in opposite direction. It records the number of vehicles traveling in opposite direction of test vehicle. Okay, so whatever be the vehicles that are traveling opposite. So here we can see the test vehicle, our test vehicle is moving in this direction. So whatever number of vehicles that are moving in opposite direction of the test vehicles are recorded by the observer number 4. Okay, so like this, the during this study stretch, each observer is assigned with their role and they perform their role till the finish of the study section. Now, by recording these data, what they do is they find out the average journey time. We have discussed about the journey time and running time in the previous videos. So you can refer to those videos regarding the journey time, running time, journey speed, running speed, and likewise. So the average journey time is found by average journey time, which is denoted by T bar, is found using the formula TW minus NY by Q, where Q is the traffic volume in one direction of the stream. Q is the traffic volume in one direction of the stream. That is, the one direction is considered, and so in that direction, a traffic volume is found out. The formula to find out the Q is NA plus NY divided by TA plus TW, where NA is the average number of vehicles counted in direction of stream when test vehicle travels in opposite direction. This means that in the study section, if the traffic in the study section is moving in a certain direction, let's say this is the direction, and our test vehicle is in the opposite direction of the stream, then the overall number of vehicles, that is, let's say 1, 2, 3, 4, 5. So the overall average number of vehicles that are moving in the direction of stream when our test vehicle is moving in the opposite direction is called as the NA. Then we have NY, and NY is defined as the average vehicles overtaking the test vehicle minus average vehicles overtaken by test vehicle. So it's a difference between the average vehicles overtaking the test vehicles and average vehicles overtaken by test vehicles. Okay, so this is your NY. TW, TA and TW. TW is defined as the average journey time when test vehicles travels with stream. So if our test vehicle is moving in the same direction of the stream, then the overall time period to reach or cover the study section is denoted by TW, and TA is the average journey time when our test vehicle is running against the stream. So if our test vehicle is moving against the stream, that is recorded in TA. Alright, so this is the formula that are used to find out the average journey time as well as the traffic volume through the floating car method. Alright. So for better understanding, let us do one numerical on this. Alright. So the question is that the consolidated data collected from speed and delay study by floating car method on a stretch of urban road of length is 3.5 kilometers running north to south are given below, and we have to determine the average value of traffic volume, the average journey speed, and the average running speed of the traffic stream along each direction. And you can see the data is summarized in the table here. So we have the trip direction, and in front of that we are given the journey time, the stopped delay time, the number of vehicles overtaking the test vehicle, the number of vehicles overtaken by the test vehicle, and the number of vehicles traveling in the opposite direction. So we have to basically find out these desired parameters. So let us solve the question. So first of all, what we'll do is we will segregate the data in terms of the direction of trip. So I have already done that. So you can see that I have segregated the data in terms of the trip direction. So the north-south trips are summarized here, and the south-north trips are summarized here. So first of all, let us find out the average value of each parameter that is given to us. So first of all, you see, we are going to take up the north-south direction, and we are going to find out the total value. So here the journey time is given, this is in minute and this is in second, right? So for what we are going to do is we are going to add all the second parameters divided by 60, so it will be converted into minute, and from there we are going to simply add into the minute value that is given to us. Okay, so if we add 32 plus 50 plus 10 plus 28, it comes out to be 120, and 120 divided by 60 will be 2 minutes, right? And if you see here, 6 plus 6 plus 6 plus 6, so we have these as a 24 minutes. So if we add 24 minutes plus 2 minutes, so that will give us the 26 minutes. Alright, so like this, so I will write here the total value as 26 minutes. In the similar fashion, the total stopped delay time will be, so I expect you to solve the question as we move along. So upon the addition, you will see that the total stop delay time will be 6 minutes. Total number of vehicles overtaking the test vehicle will be 14. Then the total number of vehicles overtaken by the test vehicle will be 20. And likewise, the number of vehicles traveling in opposite direction will be 1088. After this, we are going to find out the average value. So the average value, we have the 4 data 1, 2, 3, and 4. So 26 divided by 4, so that will give us the 6.5 minutes. 6 divided by 4, so that will give us 1.5 minutes. Likewise, 14 divided by 4, so that will be 3.5. 20 divided by 4, so that will be 5. And likewise, 1088 divided by 4, so that will be 272. Alright, so the average value of the journey time is 6.5 minutes. So average of the total stop delay 1.5 minutes. The average number of vehicles overtaken 3.5, overtaken 5, and 272. Now let us, in the similar fashion, solve for the south-north. Okay. So first of all, let us find out the total of the given values. So in the similar fashion, the total journey time will come out to be 30.4 minutes. The total stop delay time will be 7.867. So in my calculation, I have set my calculator up to 3 decimal places, right? I am using 991 MS calculator. So I have set my calculator up to 3 decimal places. And if you know how to set the calculator up to 3 decimal places, then it's good. Otherwise, I have already made a video, and you can watch that video using the link provided either in the clipboard section or through the video link provided in the description or in the comment section. Okay, do watch it if you don't know. It's a very short and a very easy video. Okay, so 10.867 is the value. Then the overtaking step will be 12 total numbers. Then 8 will be the total number of overtaken vehicle, and 716 will be the number of vehicles traveling from opposite direction. So quickly finding out the average. So 30.4 divided by 4, so that comes out to be 10.6 minutes. 10.867 divided by 4 will come out to be 1.967. 12 divided by 4 will give the average value of 3. 8 divided by 4 will give the average value of 2. And 716 divided by 4 will give the average value of 179. Okay, so now we have the data correct. Like we have find out the desired value. Okay, now let us take one direction and solve the desired parameters for each. Let us first of all take north-south direction. Okay, let us first of all take north-south direction. So if this is north, this is south, our vehicle, our floating car vehicle is traveling in from north to south. Okay, so first of all, the first parameter is to find out the average volume. So if you see, the formula for average volume was NA plus NY divided by TA plus TW, where NA was the average number of vehicles counted in the direction of stream Q when test vehicle travels in opposite direction. So taking this as the definition, can you tell me what will be the value of NA? Number of vehicles that were traveling in opposite direction of the stream. What will be the value of NA? So I am assuming that you have chosen 272 as the value of NA, that is the number of vehicles traveling in opposite direction, and that is wrong. It will be 179. Let me explain. I'll again go back here and see that first of all, like to start with a simple explanation, the Q, that the average traffic volume, is in one direction of stream. The number of vehicles in one direction of stream. Our direction is from north to south. Right? Our direction is from north to south. So whatever parameter that we are going to take will be in the direction of north to south. Okay. First thing is this. So to simply put, if we are going from north to south, then the vehicles traveling in opposite direction, here we are going to take, since the direction of stream is north to south, here the vehicles that are traveling in opposite direction of will be 179. If it is again becoming confusing, let me again explain. See, the value of NA, is average number of vehicles counted in direction of stream Q. Our direction of stream Q is from north to south. Our direction of stream Q is from north to south. NA is average number of vehicles counted in direction of stream Q when test vehicle travels in the opposite direction. When test vehicle travels in opposite direction of the stream. Opposite direction of the stream will be, so the vehicle has to travel from south to north, and then the number of vehicles that are counted. I hope it is clear. Again, I'm going to repeat. It's a very confusing thing. Like many times in books, when we see this, we get confused and see and like assume that the question is wrong. I'll again repeat. NA is average number of vehicles counted in direction of stream Q when test vehicle is moving in opposite direction. Our test vehicle has to move in the opposite direction of the stream that we are considering. The stream that we are considering is that our test vehicle is moving from north to south. Our test vehicle is moving from north to south. So the stream is north to south. So what is the average number of vehicles that are counted by the test vehicle when it is traveling in opposite direction of the stream? And that will be 179. So here our direction of stream is north to south. So whatever parameter that we are going to take will be from north to south. Okay. So doing so, our value is 179. The value of NA, Q is NA plus NY divided by TA plus TW. Right. So our NA will be 179. Okay, our NA will be 179. Our NA will be 179. Now what is NY? What is NY? Again we will see. NY is average vehicle overtaking the test vehicle minus average vehicle overtaken by test vehicle. Right. So it is a difference between the overtaking vehicle and the overtaking vehicle. Our overtaking vehicle, the average value is 3.5 in the north-south stream. That is what we are considering, right? So, and the overtaken will be 5. So, NY will be 3.5 minus 5. Then we have TA. TA is defined as the average journey time when test vehicle travels against the stream. Remember, the test vehicle is traveling against the stream. What is the direction of our stream? Direction of our stream that we have considered right now is north-south. It is north-south. Against the stream will be south-north, right? So the average journey time taken by the test vehicle when it is traveling against the stream, so south-north. So that will be 10.6. Okay, I hope you are getting it. If you are not able to still understand, then it's okay. You can post your doubt in the comment section. Not a big issue. It's a bit confusing in the first time, but if you understand the concept, then it becomes easy. Okay. Then we have TW. TW is defined as the average journey time when the test vehicle travels with the stream, right? With the stream. So our north-south direction, what is the average journey time here? What is the average journey time here? Average journey time is 6.5, right? So average journey time is 6.5. Okay. So all we have to do is we have to just solve it, and upon solving it, we will get the value 12.589. What is the unit? What is the unit? Since it is traffic volume, what is the unit of traffic volume? The unit of traffic volume is vehicles per unit time. So vehicle, since these are in minutes, so vehicles per minute. So it will be vehicles per minute. So this is the first part of the question that we have found out. We have found out the average traffic volume in the direction of stream. Now let us find out the second part. The second part of the question is that we have to find out the average journey time. So again we have discussed that the average journey time T bar, is found using the formula TW minus NY by Q. TW minus NY by Q. TW we have already already discussed. TW is the average journey time when test vehicle travels with the stream. So that is, so our second part, T bar is equals to TW minus NY by Q. TW is the average time with the stream. So here again the average time is 6.5. So that will be 6.5. NY we have already seen here. NY will be minus 1.5. Q we have found in the step 1. So Q will be 12.589. Solving it, the answer will be 6.619 unit. What will be the unit? Unit will be minutes. Okay, so this is the average journey time. Right? Now let us see what the part 3 says, that we have to find out the running speed. We have to find out the third part says that we have to find out the running speed. So for here the running speed is a speed that takes running time as our as the time of consideration. And running time is, what is the running time? Running time is nothing but the journey time, the average journey time minus the stop delay that has taken place, right? So the average journey time we have seen, average journey time is 6.619, and the average stop time when the vehicle was traveling from north to south, the average stop time was 1.5 minutes, right? The average journey time was 1.5 minutes. So this will be 1.5, and if we solve it, we'll get the running time as 5.119 minutes. Correct? Now we know speed is equals to distance upon time. Speed is equals to distance upon time. Distance we are already given in the question. We are given this test run has been done for 3.5 kilometer stretch. So taking this distance is 3.5 divided by time. Since we have to find out the running speed, we will take running time. So 3.5 divided by 5.119. This is in kilometer, this is in minute. So to convert this into hour, we will divide by 60. So that will come out to be 3.5 into 60 divided by 5.119. Okay. So upon solving the running speed, the running speed will come out to be 41.022 kilometers per hour. This is the solution that is required from the question. So we have found out all three parameters. We have find out the average traffic volume, we have find out the journey time, and we have find out the running speed. Okay. So I hope the question is clear. So now we are going to consider for the south node. Now we are going to consider for the south node. Here now if this is north, this is south. Now our test vehicle is moving in this direction. Direction of stream is from south to north. Direction of stream is from south to north. So let us. So I'll again request you to please, if you have not done solve the question till now, I'll request to pause the video and try to solve it for south north. Okay. So for your reference, I will just post like this is the overall value that we have found. You can pause the video here and try to solve it by yourself. Okay. So if you have done, it's very good. Now let us solve the question and see if you have done right or wrong. So first of all, we have to find out the value of Q. right? And the formula for Q is NA plus NY divided by TA plus TW. Now here again, the same thing is what should be the value of NA. Again, I will just for discussion purpose, I will again take NA is average number of vehicles counted in the direction of stream. Direction of stream will be south to north when test vehicle was traveling in opposite direction. That is, what was the what will be the opposite direction? Opposite direction will be north to south, right? So that average number of vehicles when our vehicle was traveling in north to south, opposite to the direction of stream that we are considering. So here, if we see that value is 272, right? The value is 272. Okay, so the value is 272. I hope it is clear. If it is not, again suggest you please post it out in the comment section. Okay. NY is overtaking minus overtaken, so it's very easy. Overtaking is 3, overtaken is 2, 3 minus 2. 3 minus 2. TA and TW, the value of TA is when the vehicle is traveling against the stream. Against the stream is 6.5, and with this stream is 10.6. Okay, so it will be 6.5 plus 7.6. Upon solving, the value will be 19.362 unit vehicle per. If you have solved a question by yourself, make sure you have mentioned the unit also. Make it a habit that you should write unit also, because marks get deducted because you forget to write the unit. Okay, so again going for T bar, this is the part 1 that we have solved. Now the average journey time T bar is TW minus NY divided by Q. TW is, what will be the value of TW? Again, TW is traveling with the stream, right? When test vehicle is traveling with the stream. So that will be how much? 7.6. NY 3 minus 2 is 1. Q we have already found 19.362, so we'll write 19.362. Upon solving, the average value is 7.548 unit will be minute. Okay, so if I have done any calculation error, do let me know. Okay. Then the third is the running time. Running speed. The average running speed. The average running speed. So to find out the average running speed, we need the average of running time. And running time, just we have discussed, is the average journey time minus the stop delay. The journey time in south-north direction was, the average journey time was 7.548. Delay in direction was 1.967. That was 1.967. So upon solving, we have 5.581 minutes. Our running time. So the running speed will be the distance upon average running time. Distance upon average running time. So distance is 3.5 kilometers. Running time is 5.581 divided by 60. So I'll take 60 here. Upon solving, the answer will be 37.65 kilometers per hour. Okay, so like this, the questions related to the floating car methods are solved. So I hope with this lecture, this floating car method is very clear to you. There is no doubt. And again, if you have any doubt, you can ask in the comment section, or even if there is some suggestion regarding the video and there is some topic over which you want me to make the video, please do post in the comment section. Okay, so I hope the video served your purpose, and if so, like the video, subscribe to the channel for more videos like this. Thank you for watching. Have a nice day.